And we're live. Hi, everyone. Welcome to another Insight.net. My name is Cecil Phillip, and my friend and co-host here, Rodney, who's also our guest today, which is very cool.
Makes it easy, right?
It makes it super easy. This is officially our first stream of the year. So, one, thank you for joining us. Happy New Year. And if you're watching this video later, definitely hope you found some value out of the things that we're going to talk about today. So in this particular stream, Rodney's going to talk to us about functional object-oriented programming, which for me sounds like we're supposed to be going this way, but we're going this way instead. Like we're bringing them together versus like, instead of diverging principles, we're converging. We're bringing them together, right? Is that
Yeah. It's a cohesion thing.
Okay. So I'm really interested to hear about that. One, because I feel like F# and just functional programming in general, not just with F#, but the functional style of programming has been something that's been on my learning list for at least 5 years or so. It's always like, oh, I'm going to go learn this functional thing. But then, we go back to work and I'm like, okay, well, nothing I do at work involves this. No projects that I work on involve this, whether they're side projects or work projects or even little things I tinker around with my son. I'm like, nothing I do involves functional programming. So it always kind of like, it comes and it goes and it comes and it goes. And you ever feel like sometimes you're in that cycle of you just keep relearning the same thing all the time? So
that's kind of exactly how this all came about. Was I am a functional programmer, right? Because I do RX, and I did the same thing. I taught myself RX, and then didn't have any real use cases for it. Then on the job one day they were like, "Hey, we need to do real-time events," and I was like, "Wait a minute, RX can handle that."
Yeah, exactly. So, and I'm also a big fan of RX too. We got to make sure we do some shows, a show or some shows on RX at some point in the future.
Oh, for sure.
But yeah, I'm really interested in learning about what you learned about functional programming. But before we do that, I'm going to share my screen real quick, and we're just going to go through a couple of updates, share some links, and talk about some stuff that's been going on in the community. So first thing, again, if you're like me and you want to learn F# and you're interested in learning how this functional thing works and how it kind of came about, if you head over to fsharp.org, right, and you go to the learning section, there's a part here for F# for C#, Java, or Python developers. And I thought that was a good starting place for me because I know a little bit of Python, I know some C#, been doing it for years, Java not so much. But if I'm an experienced developer, relatively, you know what I mean? And so now this will take you over to this site that says F# for fun and profit, right? And asks, are you an experienced developer? And kind of walks you through some of the things that can get you up to speed with F# really quickly. So if you're interested in learning, again, and it's something that you really care about, you want to spend some time doing, this is a good free resource that you could use. And I think it also links out to, other books, tutorials that may be free or paid, just depending on what path you choose to take. And, other, blog posts and articles and things of that nature. So if you're interested in that, check out fsharpforprofits.com. Next link I want to share with you, and Rodney and I were just talking about this off stream, and it was the fact that, I was having a conversation with an advocate, and, we're talking about events that we're going to go to for 2023 and what we're going to do and, goals and objectives. And I said, I really want to do a lot more local meetups and code camps and stuff. And she's like, what's a code camp? I was just like, you don't know what a code camp is? Right. And two things happened in that moment. One, I felt like super old because I'm like, code camps for me were just like the beginning. For me, like code camps and meetups were like the beginning of my career. Like that's just how I started. That's how I learned about everything. Right. Like this is before Twitter and before GitHub and before, all this social media developer stuff happened, right? Like social networking was like networking in person, right? And we went to code camps and meetups, right? Yeah. And but the second thing that happened is I realized, like, as a person that's been here a little while, maybe I don't talk about these things enough, or maybe we don't share information about like, code camps and things of that nature, right? Again, we're always talking about the big conferences we go to and the, big live streams we do, but we never really talk about some of these more, just as technical local conferences with local speakers. Some of them might be happening in your city down the street, maybe a block away from your house, that happen, fairly regularly. So this one is in Orlando. I don't live in Orlando, by the way, but the Orlando Code Camp is happening in March. I wanted to give them a shout out because they're friends of mine. you know, pre-pandemic, so I want to say 2019 and prior, I used to go to this event every year. And I don't know if they had it last year, but this is going to be one of their post, I don't know if I could say post-pandemic, but not that everyone's back outside, the back outside era. They're going to be having these events again. And so I actually submitted 2 talks because I'm like, again, we've been going to all these conferences and live streams and whatnot. Like, let's get back and support our local developers, our local communities and stuff, and do some of this type of stuff. So, I'm gonna support this one. Maybe you could search your community and your network and your city and stuff like that, and maybe there's a local meetup that you could speak at or a local co-camp that you could speak at, and kind of just let's keep these things going, right? Like, let's not let folks forget about like the meetups and the code camps and where these things kind of came from.
Yeah.
And last thing I want to share with you folks, our friends at JetBrains, every month they do like this .NET annotated monthly. Our friend Rachel Appel, shout out to Rachel real quick. She usually helps put these things together for us. And if you're not familiar with what this is, essentially it's like a collection of .NET news and links and tips and tutorials. A lot of these things have been written by various members of the community, maybe written by some of you folks that might be watching right now. And then just kind of goes through all of the various topics of .NET, right? So whether we're talking about, here's one on CQRS and Web API, and I'm sure I'll find something in here that says Maui. Here you go.
Right there.
Right? There's a couple of Maui blog posts and pattern matching, right? So there's something here for everyone, right? You don't have to read all of them, but if there's something here that you might be interested in or a part of .NET that you're like, oh, okay, that sounds really cool. Like, definitely make sure you head over to the blog.jetbrains.com/.net, and then they have their annotated .NET monthly one. Oh, look, does anyone hear about colorful ASCII Christmas tree in C# by ChatGPT? Okay, I mean that's the thing too, right? I haven't played around with the ChatGPT stuff myself yet, but I guess it's a cool thing. Everybody's playing around with it now. So if you're interested, here's an article that kind of goes through and talks about some of that stuff. Okay. So what I'll do, I'll take some of these links. We'll make sure we put them in the description of this video, and I'll also put them in the chat. So if you're watching live or you watch this later, you should be able to take a look at these links if you're interested, learn about F#, learn about the code camps, and also make sure you check out our folks at JetBrains with this .NET annotated monthly. Okay, now that that's done, I'm going to take my screen off. Rodney, tell me about this functional object-oriented thing, right? Like, tell me how you even got here, because again, in my mind, like those topics go this way, and then now you're trying to bring them in this way. So like, how does that work?
So I'm gonna take a trip in the Wayback Machine to like let's call it like 2015, 16, okay, somewhere. And I was fresh Xamarin developer. I had been an ASP developer for years. I've been doing .NET forever. But I was finally getting into mobile, and I started to understand this concept of reactive functional programming, keyed by reactive extensions in C#, which is basically iObservable. So it goes from a pull-based model to a push-based model. So I'm very much the type of person where I teach myself things like this at night when I should be sleeping. I'm sitting up, reading and trying to figure out how to push the envelope and learn new things. Well, this Christmas time, I finally, I think I read it, but I didn't read it but I reread a particular book. I've been trying to learn F# to go along with my my C#. And I say I'm a functional programmer because I do functional programming, but I realize I don't actually do functional programming. I do like functional programming light. That's kind of what this whole thing is about today. Is kind of that journey that I took, the learnings that I have had. Because people who don't know this about me, I'm actually a developer by day. I'm boots on the ground. I write code. I have stories assigned to me. Like that's my life. So one of the apps that I'm currently working on has done a large scale RX investment. Right. And we're really invested in this responding to mutations of properties. So this Christmas, I pulled out a book, and this is where I'm going to share my screen. Where's the button? Rodney, click buttons. There we go. I can click buttons. I promise I can. Let's share this whole screen over here. There we go. That screen one. There we go. Share. Okay. There we go. So I read this book, Domain Modeling Made Functional. Because I also, we do DDD where I am, and this is not going to be a DDD talk. We're going to talk about DDD on a completely separate day. But this book basically changed the way I viewed reactive extensions and functional C sharp. So it took a problem domain and walked through the entire creation of a workflow cycle. And one of the things that we do at my job is we have these concepts of workflows, which are just, anybody has a workflow. It's a starting point, some decision trees, and an end point, right? And hopefully we get to the end in some pristine state. Yeah.
Got it. That makes sense.
So the concept of this kind of came from here. And as I was looking at some of the code for the book, I had one of those awesome light bulb moments, and my brain just legitimately shut off and had to reboot. And I kind of started a talk, and this is kind of what this stream is about, is kind of the learnings that I had that are going to be going into this talk about functional object oriented programming. So that's kind of how we got here. I'm gonna pause.
Okay. One of the things that I always think about is when folks ask, "Hey, if you do this during the day, like if your day job is LanguageExt," because for most people, like they usually have like a primary that's like their day job. Like, so my primary is usually C sharp. Sometimes I do a little JavaScript, sometimes I do a little Python, but like primarily, like that is the thing that I do. And they're like, okay, well, if primarily this is your thing, why would I want to learn something that's a completely different paradigm? And I think it's worth pointing out the fact that, even though I don't do F sharp or functional programming constantly on a day-to-day basis, I think it's always interesting to learn just different perspectives, right? Because as we get these different perspectives, you might be like, oh, okay, that thing, that one particular thing out of maybe many things that you might have learned, that's really cool and that's really interesting. And oh, let me see how I could replicate that in my day-to-day, in my primary, right? Or if not, how can I like bridge that and that together? Maybe some interop or something like that. Like, how can I either bring them together, or I can either bring it over to my side? But the way that I always look at it is like, learning, it's never a bad thing to learn new stuff, but then even more so, how could you learning new stuff make you a better developer? So which is why one of the reasons why I'm like, okay, the functional programming things goes there, but if we could bring it in, one, maybe you can make it a little bit easier, for folks to understand functional programming because they could add it to something that they already know. And then two, if you can add it to something that you already know, that makes it a little bit easier for you to like make a step to the right or the left and try like maybe a fully functional language, or maybe a semi-functional language, because languages are all jumbled up with features these days. You know what I mean? And then kind of learn a little bit more about what those ecosystems are like.
So it's funny, right? It's almost like we prepared this, even though we didn't, right? That's exactly what happened, right? Like I looked at F sharp, and I've gotten into some spats with some people on Twitter, and I know that the F sharp community, I guess, has a stigma of being, I don't know, less than ideal when it comes to talking about things. Like everybody's always like, oh, well, F sharp does that already, and C sharp got that from F sharp, and blah blah blah. Okay, I get it. But I was looking for exactly that. How can I take these concepts, right? And like, let's take a step back and talk about these concepts real quick, right? We have the traditional object-oriented model, which uses things like inheritance and other. Hold on, I got all the things right. Yeah, it uses things like abstraction and encapsulation, inheritance, and polymorphism to do these things. But there's also this functional side of the world where we use functions for everything. Right. And that was like, that's very intriguing to me, again, as an RX developer. So I was looking at some code, and we're going to jump into some code now, unless you have more things for me to segue out.
Yeah, no, go ahead and dive into it. Perfect. I think and while you're getting that set up, I think another interesting thing, particularly in the .NET space, that I've noticed is that like the more features that keep getting added to C sharp, I don't know, 9, 10, 11, 12, 13, 14, you know what I mean? Like the more functional the language is becoming, right? So it's like, even though we don't necessarily make the effort to, learn functional programming and be there as much as we could, you know what I mean? It's like the world, or like, the ecosystem is kind of forcing us down that path anyway. So I'm like, okay, well, if that's the case, then why not go ahead and make the time to kind of learn these things on yourself and understand it, because we're going to get it one way or another. It kind of feels like
it feels like the entire world is going functional, and that's exactly it, right? So there's a paper, and I can't remember, Out of the Tar Pit, right? And Out of the Tar Pit talks about exactly that. in software applications. The
Right.
major complexity in software applications is mutable state. Object-oriented languages have to mutate state and respond to the mutations in the state in order to do things functionally. But a true functional language, a pure functional language, doesn't have that concept. It's actually based on a concept of immutability. So it takes the most complex thing that we deal with as software developers out of the equation.
Right.
Right.
Okay.
So that's the main difference that I realized when I was looking at RX. RX currently is all about dealing and handling and reacting to state mutation, whereas F# was like, hey, we don't mutate things. You can mutate them, don't get me wrong, but we don't mutate them. Instead, what we do is we give you a pure function, and I'm not going to define it for you perfectly, but a pure function basically is a function that is idempotent, and you take it has a input and has some output, and the output is always going to be the same, right? So
Yeah.
the concept of the purity of these functions and the ability to just say, hey, I've got legacy state, let me create new state and pass the new state down, became very, very intriguing to me. To your point about C# becoming more functional, if you've ever used LINQ on IEnumerable, you have done some level of functional programming, because that is a Lambda expression. It is a function that is defined and executed at a later point in time. That is the basis of what it is, right? So like that was the beginning of C#'s foray into functional from what I can remember. It probably had something before that, but irrelevant. So if you're a C# developer like me, F# is going to look somewhat odd to you, and that's fine. I'm going to point out something very specific, and then I'm going to switch back to a C# example. This right here, and hopefully everyone can see this, and it's nice and big, and hopefully, yeah, it looks good enough. So this validate order has a concept where it has dependencies, right? So like we talk about dependency inversion, we talk about dependency injection, right? A lot of people may or may not realize that there's multiple ways to inject dependencies. The major way that we see, and the way that we see abused the most, injection, right? But you can also inject dependencies into methods, right?
Right.
It's just a function signature. So that's what F# seeks to do, is a lot more functional level dependency injection. So I'm defining a type that takes a dependency of a function and takes another dependency of a function, has some actual input, and then gives me some output. And I looked at this for about 5 minutes, because it was like something about it didn't seem right. And then I went back and pulled up some code that I wrote pre-pandemic or during pandemic. Actually, this was the first year of the pandemic. I wrote this code. I wrote a app for a conference talk called Social Queue. That's the irrelevant part. The relevant part is this. And I'm going to see if I can do this side by side. I'm going to see if I can swap back and forth. Hold on. Let me see if my buttons are working. Nope, that's not what we want. Let's do Social Queue, and then let's grab Foop, and let's click this button. Nope, still not going to work. Okay, fine. My buttons still don't work the way they're supposed to. Anyway, the fact that we have this result, and we're going to talk about this in a minute. I don't want to get too much into this right now, but the fact that we have some input, some output, and some defined result that gives us a type that we can return or an error that we can handle. It physically broke my brain at that moment, because I realized in this world that I was trying to create something very similar. This is the search view model, so the search store service, right? So let's look at this. I have my dependency that I inject, right? So it's a little inverted, but I have my dependency that I inject, which is my API client. And then I use my API client to chain together these methods, right? To go to the API, right? I use the API client to go to the API and get stores. And then once I get the stores back, I use this add or update method, which puts it into a local cache, right? So now I'm using the concept of like functional pipelines to do things that a functional language would do, right? But I'm inverting it a little bit, even though I still have dependency injection and property dependencies and all of these things, I'm still able to get that proper functional feel, I thought. And this is where it all breaks down. Go ahead.
Okay, so let's talk about this for a second. So everything you said makes sense, but I think I just want to clarify something now. So when I'm looking at, right, so you're showing your C# code right now.
Mhm.
And so we're talking about doing construction injection into the constructor.
Right.
But then when you're using your API client, you're using what we've come to know as a fluent syntax, right?
Yes.
So now, again, like when we think about fluent syntaxes, I just think, oh, okay, this is like some builder pattern that's someone thought, oh, this was cool, we made it. But are you saying now, is this an example of functional programming? Is like that fluent pattern of like chaining functions together a functional paradigm?
It's a functional paradigm.
Okay.
And this is what I thought functional programming was.
Okay.
And then my brain got broken. So to your point, right? One of the main paradigms of functional programming, going back to that result, right? Going back to that result is everything is handled inline, right? So inline error check in C# would be, let me go into this function. See, I can't even do it. Let me see if I can do it. Right. So if I was to do something like an if check, right, or do like a try catch, right, like that's inline exception handling, and then I have to bubble that back up. Well, the way functional programming does it is slightly different, right? It looks at the function and says, is the result green or is it red? Is it good to go or is it bad, right? If it's good, it keeps going down the happy path. If it's bad, it gets chunked into the error section to be handled, and it may make itself back into the good state depending upon how you have your error handling set up.
Okay.
And what I realized was we wrote some global error handling for the app that I'm working on because reactive UI has a global exception handler. But what we're really talking about doing, right, is using this catch operator in reactive extensions to then return. Can I do this? Some, let me do enumerable.empty of the type, right? So that's basically what we're talking about doing, right? When we catch an exception, keep it going. And we aren't doing that right now. And this is where my brain broke, right? Because I was looking at this code and saying, how can I make this better? What can I do to make this better? And this is where I'm going to go completely off the rails. If you are a C# developer, this is going to be where we get into the functional jargon, and you're going to start looking at me like, Rodney, what are you talking about? I'm going to use the dirtiest word in all of programming, monad. Yeah.
What's a monad, Rodney? Do tell.
Well, I'll tell you this. I still can't give you, like, off the top of my head a proper definition for the word monad, what it means, what it is, right? But this is what I realized. Going back to, let me see, come on, Rodney, you can do it. Going back to this F# example, this result object is monadic in that it will return you a type that you expect and or an error. So now let's talk about the dirtiest word in all of C#, or 2 words, discriminated unions. Boom. This is where you need a discriminated union, right? A discriminated union will allow you to say it can be a valid order, or it can be a validation error, or it can be some other type, right? And that is going to be the return signature that I expect from this function. So I'm going to pause there because monads like still hurt my brain. And like, and this is where we go off the rails. And this is where we're moving from like safe C# object-oriented programming to functional world.
You know, when you said monad, immediately I'm just like, okay, I'm not going to understand anything else he says for the rest of this talk. Because I'm like, every time someone says monad, it's always followed by, I can't explain it to you, but we need it. And I'm just like, well, why are we talking about it? But what you did, what I like, and I appreciate, was that, so you talked about like discriminated unions. And for folks that don't understand, at least when I think about discriminated unions, I think about having the ability to have a result represent multiple types, right? And it could be this, or it could be that, or it could be that. But like, these are all valid representations of what we think the result's going to be. And as you're talking about it, one of the things that pops into my head was last year, you know, I started learning Golang a little bit. And Go is such a, like the way that Go does error handling, like it doesn't throw exceptions, at least the way that we think about throwing exceptions. It returns a union, right? Your union is either the result or the error. And literally like almost every function in Go is like this, right? So like, you know, there's a lot of these like if error checks in the language, right? Like if not error, then use like the other thing.
Right.
else, if error not null, use the thing, right? But again, like every function returns either an error or some, object result of some sort that you
Right.
can actually use. So as I'm thinking about that, I'm looking at your example. I'm like, okay, I got it. I completely understand, right? Because your function can have at least two states, right? It can either work or it can not work, depending on what your work is. You might have other states in the middle, but like
Yeah.
at the end of the day, it either works or it doesn't work, right? And so
Right.
now, here you're representing that using that results type.
Result.
I guess it's a
Yeah,
type
it's a result
or
type. Yep.
a
Yeah.
tuple or something.
Yeah.
But are you saying now that like that result is a monad, or is it like monadic? I guess like one of those.
It's monadic, and it now allows us to use other. And this is again, I apologize, and I will again disclaimer. I am not the authority. I am still learning,
Yeah,
but this is what I know as of today. Right? This is what enables monadic operations to happen on things. Right?
yeah,
Is it a type? Is it something? Is it an error? Right? And which way do I route it based upon that information? Right? There's this concept. So right then and there, right? Like when I realized, oh wait, we're like monads are really just the existence, or not the existence, the acceptance of the fact that programming is not perfect, and it gives you a way to handle exceptions in line, as opposed to you write 15 try catches and you got to bubble that thing all the way back up to the top, right? Like
right.
nobody wins in that world. I actually remember one year somebody wrote like 7 try catch blocks, and I had to sit with them and walk through how to debug and get their exception that they actually wanted back out of 7 layers of try catch.
Oh my goodness! Wow,
There you go.
that was
Right.
not fun.
Our code is beautiful until we start handling errors.
Right.
Right. But what these monadic operations allow us to do is handle exceptions in line gracefully, and they are less exceptional and more errors because they aren't exceptions. We expect them to happen. Let's talk about going against the database, right? I could call the database, given an ID, and get a valid value, or I could get an error, right? That the resource doesn't exist in the database, right? Are those really two separate things, or are they part of the same thing, right? Monads are what we use to model them as the same thing, as opposed to, hey, I have a process and some exception happened. We don't care about that exception, right? What we care about is, can we continue to give the user a good experience while handling any exceptional or understood cases that may happen?
Right. And so here's another question, and this might be us going off on a tangent a little bit. So
Uh-huh.
now, when you have these constructs, right? When you have like these monadic functions, I don't know if that's accurately using the word or not, but
I don't
if
know
I have
either.
these functions that represent these different return states, right? It
Yes.
works or it doesn't work, or
Right.
maybe there's like it's still, maybe there's something in the middle, right? I feel like now the consuming code is now going to be littered with like these if else checks,
Why?
right? Well, because it was like, well, if it's an error or if it's not an error, right? Like I have to check and see what it is because I need to know like what branch I need to go down, right?
Well, that's the power of these monadic operators, is they handle that for you.
Okay.
And this is where the mental shift is hard, right? You mentally have to change the way you look at it and stop thinking of it as an either or, and looking at it as a result. I call some API, I get some result. Is it successful? Is it a failure? Right? Like that's what I'm looking at. Right?
Okay.
So it's no different than looking at a HTTP web request and saying, is it a 200 status code? Is it a 302? Is it a 404? Like it's no different than that. And yes, the if checks get dirty, but this is where my learning came in, and this is where this whole concept came about.
Mhm.
Was I looked at this and I said, well, how can I use this in C sharp? Right? Because I'm a C sharp developer. And I already do what I consider to be functional programming light. So how do I now get these monads into C sharp to allow me to handle these errors, no longer exceptions, these errors in line, and create workflows around them, right? And with everything, you look for a valid domain to do this in, right? Because like you wouldn't probably necessarily do this for everything in a C# app because everything wouldn't be considered a workflow. But what is a workflow, right? What would we consider a workflow? And this is where it all kind of broke down for me. And I'm going to share this. No, wait, this is the wrong button. Rodney still can't click buttons. There we go. Here we go. This is not as pretty, but we'll show it anyway. I wrote this diagram using a new Mac OS app that I found called Diagrams, which I think I'm going to buy a license for. It just expired today, so I'm pretty sure I'm going to buy a license for it because it gives me Visio style ability to build workflow diagrams, right? So, you know, the question I always get is, hey, Rodney, can you give me some like I've seen the search example in RX 500 times and I still don't get it. Hey, Rodney, can you go write me some code side by side and show me how to do it in imperative and how to do it in declarative? No, I'm sorry. I'm not going to break my brain to figure out how to write your code bad to then show you how to write it better. Right?
Right.
So instead, what I chose was a domain that every single application has to go through at some point. OAuth, right? How do we go from I have my, hold on, let me grab it, right? I have my mobile device, right? And then I go from having my mobile device to clicking on the app and getting authenticated to the app, right? Everybody's got some bad code written for that somewhere where they've got a bunch of if checks and they probably got to go against the file system to look for either the user ID or the user token or some refresh token, right? Like everybody's got that code somewhere, right?
Right.
So you go find your code, put it against my code, and then you can tell me what the difference is. That's how I'm looking at it, right? But anyway, I modeled a workflow of authentication, right? So the concept is I go get the user account, and then this is where the monadic operations come in. You'll notice here that there's this either, right? There's this concept of it can either be a success or a failure, right? So that makes it very easy for decision trees, right? Because it's either an error where we go create a user account, or we know that the user account exists and we can pass it on down the line, right? So I drafted out this whole thing, and I'll go ahead and tell you, I haven't implemented the whole thing yet, but I have gotten it working against an actual OAuth endpoint, and I am liking the results already.
Okay. So here's my question.
Yeah, sure.
So as you're talking about monads and these discriminated unions, and I'm thinking about practical examples that I could wrap my head around. And the first two things that came to my head were task of T and nullable of T.
Yeah.
Only because like those represent different states, right? So for folks that don't know, so like task of T, I'm thinking about like some operation. It could be successful, it could error out, it could be canceled. Like there's different states that they could be, and it can also have a result or not, right?
Right.
And then I think about nullable of T, which is a little bit, you know, fewer states, right? It's either nullable or it's not nullable, right? So now, would you consider those to be like monadic types in C#, just because like they represent states and like it could have a result or not, or it could be successful or not? Like, are those examples of that or not really?
So again, not being the authority on this, I can't say yes or no, but I'll tell you what I think.
Okay.
What I believe is that task came about to solve the same problem that had already been solved in functional programming, right? Void is the absence of a return type. And anyone who's ever heard me talk about void and async and don't use void and async knows that I am on the soapbox at least once a year. Void is the absence of a return type, right? So if you are sending off some promise, I'm gonna use some JavaScript terminology, some promise or some future that is going to return a value at, let's say 10 hours from now, can you rely on a void lack of a return type to give you that functionality?
Yeah.
Right. So a task is basically the beginning of under functionality. Must return a valid type, which is a functional paradigm. So I would say yes, it's going to be the poor man's C# version of monad. To answer your question.
Okay. I mean, so at least it's similar enough, right? Because again,
Yes.
I'm thinking about things that like represent different states. And as you're talking about like these discriminated unions and monads, I'm thinking about things that represent different success or failure or
Right.
not completed yet states, right? And so in
Right.
my head, like those would be for me examples that I can kind of understand.
Right. Yeah. Well, and that's exactly it, right. Like and there's that same concept exists in these monadic operators, right?
Got it.
So the answer to that is yes. You can look at these things as a task. A task is, and it's funny because this library that I'm about to show is kind of task oriented, meaning that it works on the concept of tasks. But
Okay.
you are going to send some request out and you're going to get an answer back. You're guaranteed by the contract to get an answer back, which you don't get from a void return. So now you can determine whether or not it's successful, whether or not it's an error. If it's an error, what is the error? And all of that information can be available to you by unwrapping the return type, which is the task, and seeing what's in that bucket, that envelope, that soap envelope. Yeah. What's in that envelope? Sorry, bad jokes from a long time ago. What's in that bucket? And now I can reason about, is it successful? If it is, do this. If it's not successful, do this. Right.
Yeah.
But the difference is I can do it without if checks and I can do it inline. And that's the key. That's the key to this monadic concept that I'm finding, is that it allows you the ability to project both success and failure states from a single object, which is something normally not achievable in C#, right?
And since you've mentioned RX, right, React as extensions a couple of times, and
Yeah.
RX is built on the interfaces of iObserver and iObservable.
Yes.
I'm guessing, would you consider those to be somewhat monadic as well? Because I'm thinking, as you're creating like these pipelines of processing, like there's the states of, is this a successful state? Is it a failure state? Is it a cancel state? You know what I mean? Like you have these different states, and then now you create this functional chained pipeline to kind of handle those states, and either, okay, well, if it's successful, do this, and if it's not successful, do that. But then they kind of like, you kind of do it in like that fluent like syntax, right?
Yes, sir. So it's almost like we do this a lot, right? So yes, and because I use RX, right, I don't skimp. Like anyone who knows me will tell you I don't skimp when it comes to it. I'm all in on it, right? So it can be used to model asynchronous programming, right? No different than a task. So now what I've done is I've got my iAuthenticator interface, and this is where like I'm going to take a step back in a second, and we're going to have to answer this. But like, yeah, I'm using this iObservable to basically be the same thing as a task or just a task, right? This unit is analogous to a task. So
are you using default interface implementations? Is that what you're doing?
That's the spicy bit I'm gonna show you at the end, and
Okay,
why
all
I
right.
like you're jumping ahead. You're jumping ahead.
Sorry. I just noticed. Like, okay, go ahead.
It's okay. So yes, that's exactly it, right? Like this is the equivalent of if I was to write this as task, right? Those things are equivalent, functionally equivalent to some degree. The difference is that when I write it as iObservable, I can use these pure functions and fluent syntax to chain together a pipeline or a workflow of things that can happen during the processing of that task. That's the difference. That's why I bought into RX. That's why I will continue to use it.
Got it.
But here's the fun, right? You'll notice, hold on, let me see. Where did Rodney do? Am I smart enough? Am I smarter than a fifth grader? I am. I'm not. Where is it? Where's my code? What'd you do with my code, Cecil?
Which one are you looking for? The
I don't know. Who knows? I got this. Let me find result. There we go. Result, not task, result.
Are you looking for like an implementation of the function, like where you called it?
Yeah, this is what I'm looking for.
Okay.
So we get into this monadic concept, right? So like, here we go. Rodney's going to bring up a thing, and we're going to talk about the thing, and we're going to do the thing. Where is it? Where's my, here we go. So I had, years ago, pre-pandemic, somebody brought this library to my attention, right? And for better or worse, I did not really pay attention to it because I didn't fully comprehend it, right? What this library actually does, right? And I'm giving it to you folks now. This library bridges the gap for functional programmers in C#. This is a language extension pack So I know Nick Chappis recently did a thing about using the functional concept of creating domain-specific identifiers with a particular library. This library allows you to do the same thing, but it does it in a Haskell-style approach. And Haskell is like one of the more popular functional programming languages. Like a lot of people have cited Haskell in their functional talks.
Right. Okay.
Well. So what this affords me, and this is a whole bunch of information, but we're going to dig into the parts that I care about, which are here.
Well, like you said, this is like a whole library. So this is like a NuGet extension. Like I go into NuGet and I can like NuGet install language extension and
I'll show that to you in a second. I'll show it to you in the project in a second.
Okay.
Notice that it has an option type. So you talked about nullable, right? In F#, there is no well, I can't say that. The concept of nullability doesn't exist in a lot of other languages, and how they handle it is by this monadic operator or monadic type. There we go, of option, right? What option says is it's another result type, right? Either I have an integer or I don't, right? So instead of having to check me for null, you just have to check, am I some integer, right? Real simple. So now you are always returning an option, a result, something that is an actual type as opposed to, again, void and null, the absence of a thing. The fact that we as C# developers have become extremely comfortable with returning the absence of a thing is destroying code bases all over the world. I said it. You can be mad at me. Find me on Twitter, and we can get into the holy war of this concept. Like, you guys really don't get it. Like, checking for null everywhere is ridiculous when you can bring the null check and encapsulate it, and then make sure that every public consumer just says, do I have a value or don't I? And that's a very important binary decision. And I'll show you later how you can actually write a unit test to determine whether or not the thing has something or doesn't, right?
Right.
Anyway, so it has access to all of these different things. It's got atomic bits. It's got maps and hash maps, which are all things that if you're a functional programmer, you'll understand. If you're not, you think of it a map as a
dictionary, right?
As a dictionary, yeah. It's a lookup, right? It's a lookup for something in the future. You have your optional value monads, right? So option async, option unsafe, either unsafe, try, right? Validation. So you can actually write validation and write applicatives, which I'll also show you here in a minute, which is a functional paradigm where, like, when you read it, it didn't make sense to me. Like, I read it and it did not make sense to me. But what I've learned since then is applicatives are basically a function over a set of functions. So think of a value tuple. Think of it as a value tuple, but instead of each value in the tuple providing you a value, it provides you a function that gives you access to the value.
Okay, got it.
That's it, right? So instead of tuple of t, it's tuple of func of t, right? That's the difference. So,
so if we think about LinkedIn, then I'd be, because again, I'm trying to map it in my head. So I'm thinking about LinkedIn, I'd have a tuple that has a collection of getter functions. Like I'm going to get the value, right? Like not the value, but functions that'll let me, that I could call get or retrieve or whatever to get the value back.
Right. Okay. Right. And I'll actually show you an example of that here shortly. And I'll also go and say there are some samples in this library. And again, somebody in the RX community told me about this 3 years ago, and it wasn't until I started looking at F# and looking at a pure functional language that everything made sense. And we'll actually look at a couple of these examples. And I know that a lot of people will say, when they look at the example, because I did as well, okay, this is like a hello world style example. Give me an actual example. Well, this Contoso app is a proper web application using monadic functions and the mediator pattern, specifically the mediate R library from Jimmy Bogart, and it's repositories and everything. So it's showing you how to build a web app using these paradigms, right? And I'll also point out that this language extensions was built more for people that use task-based promises than observable-based promises. And there's functions in there that allow you to do mappings and other stuff. And again, I can't give you the full rundown of a functional programming language today, but kind of here we are.
Right.
So, oh, that's definitely not the right code. Where am I looking? Okay, so yeah, so let's talk about this in my sample code because I feel like mine is a little bit easier to reason about than some of the others because it's a simple enough domain. So okay, I have an I authentication client, which is going to go against my OAuth endpoint and log in, right?
Mhm.
I, instead of getting a task of T, I am getting a task of result. Now, this result is slightly different. And again, it's more Haskell based, as I understand it, than F# based. But what it allows you, and you'll see there's two constructors. If I can, yeah, here we go. These two constructors. It's a result that takes a value and it sets the state to success, the value, and sets the exception to null, or it takes an exception and gives you a faulted state and gives you access to the exception, right? This is the key.
Okay.
The fact that I can take a single wrapper object and put something in it and say it is either the value I expect or an exception that I got is very relevant when I'm doing something like login, right? I've got to hit a HTTP endpoint. I may get a timeout exception. I may get a 404 exception because the developer who did it, if you're like me, fat fingered the URL the first time around, right? Like there's multiple reasons why I could get an exceptional case from login, but now instead of me having a just this type, which is a result, which doesn't give me any good value, right? Now I have this result operator that allows me to reason about what happened during the login function. Was
Okay.
it faulted? Why was it faulted? And it will give me access to that thing. Now, this is where it gets fun. Let me click buttons properly. Usages. Here we go. Here's tests. Here we go. Okay. So I'm going to point out that to get to use the API surface, I mean, make some writers not being my friend right now. I got to find out how to turn that off specifically for demos. Yeah. The whole
The,
it
the
having
white
the
space thing.
yeah no, not the white space, specifically the extra it telling me what it's returning, right? Like it's telling me the return type here.
Oh yeah.
So
I,
so
I I used to know how to turn it off. I'll find it and see.
it doesn't matter. It's irrelevant, right? The important point is this. This shows you how we can actually use this API surface, right? So I'm creating a client that gives me a successful login, right? And then I'm going to pass this into my actual test, right? And my test basically says, given an authentication client, right? When I actually use my authenticator to authenticate, I expect to get a result, right? I expect that regardless of whether or not it's a success or a failure, I will get a result. And I can write a unit test against that. I'm explicitly showing you unit tests because I am a tester, not a tester. I am a person who subscribes to testing and test-driven development and behavior-driven development more so. So I like to prove everything can be done headless, right?
Right.
Because it's less important. So again, right, like I'm now able to write explicit tests against whether or not I get a return value from the internals of this. And this is where it gets weird, right? Because and so Cecil, you pointed out that I'm using default interface implementations. Here
Mhm.
is why. I started playing with the fact that I believe I can use default interface implementations to hide the monadic bits in the implementation details and only use publicly exposed the things that I want, right? The things that don't have monadic operations, the things that have proper completions. So I'm trying to encapsulate my workflow inside the default interface implementation
Mhm.
and then give you access to like let's go look at one, right? This one has an implementation. This is actually a good one, right? So notice I'm using explicit interface implementation. So the only way you'll get access to this is if you explicitly use the interface, right?
Right.
So if you're not using the interface, right, like if you're using the concrete type, you won't get access to it. But it allows me the ability to say, hey, I'm going to give an implementation to my monadic bits, and then I'm going to use a default interface implementation to just unwrap it. Simple enough?
Got it. Okay. 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 So, like you said, from a consumer perspective, if I'm just using not the interface type, but the implementing type of the interface, then I don't need to worry about those other things that are there, right? More
Right.
so I just need to be concerned about like those default implementations. And I can still override them because it's an interface.
Right.
But again, like out of the box now, like these are the things that I have to work with, and I could focus my usage or my consumption of the interface based on. So right now you have in like login and get current user, right? So like those would be the two things that we could just. Well, I'll just use these, and I'll like won't worry about those other things at the bottom.
Right, because what it does is it hides the workflow implementation, right? That pipeline of decision trees, it hides it all behind this login method, right? But I still have access to it. And this is where like the monadic operations are important. And I'm not using the library the way it's intended to be used. There's some RX functions, and I don't fully understand how to use them the way I want to yet. So, for now, I'm just kind of using it the poor man's way. But I can take my result, which is an either, right? It's either an error or a user account from the login, and then I can make it an option. And then I can say, hey, where this option is some value, right? It's not faulted, right? And I can also do like dot is none, right? Because it's an option, right? None would be the null case, right? But like it is some.
So is some means like there's something there.
Right. There is some user account. So now I can say that this operation has succeeded. Now, again, this is not the full login pipeline that you saw on that bit, but it gives you an understanding of how I'm now able to use these monadic operations to determine when errors exist in my API surface. And all it took was me changing my mental model to say, when I call a resource that I do not control, return either an error or the type I expect, right? That's the only shift I had to do.
Right. Got it.
Right. And this allows me the ability to play on a lot of other things. And I'll kind of show you some more examples. Right. Okay. So again, we talked about the fact that this paradigm of coding is immutable. So a lot of the examples have this concept of an interpreter. And the interpreter basically just takes these either statements and chains together some more pure methods to allow you to hide the immutable aspect behind it, right?
So what's the difference between either and option? Because I mean, like phonetically, it sounds like the same thing.
Either.
It's like either it's successful or it's not, right? So if I have the option.
Well, option is a result. Either is kind of like the transition. Does that make sense? Like either is option is the state, and either is the transition to get to that state.
Okay.
And either an error or a valid type, you can map me accordingly. And that's exactly the thing I want to get into real quick, right? Because there's these concepts in functional programming called like bind, which is really just a select many under the hood, and some other things that I can now use to unpack this either, right? And this either, right? When I go to create an account, I get a account ID. So it could be some GUID, it could be an email address, it could be an actual user ID without any email attached to it, right? And I say the string is null or white space, right? If it is null or white space, I want to throw an error, right? Because I can't create a user account with no string, right? But if it is, then I want to go ahead and create a new user account with this account ID, right? And remember we talked about types, right? And using F# typing. I have a user account ID, which is a new type, which is Haskell's new type concept of user account ID. It has a value of string, and I'm even able to, by type definition, tell you the length of the string, right? So if I send in an empty string, this thing will fail.
Got it. Okay. So then, what I guess what I'm looking at, does that say it could either be 1 to 50? Is that what that means?
Yeah. Sorry, it says that the string length is either going to be 1 to 50. Yes.
Okay, got it.
Right, and you get that by default by including this library. You get the new types. There's a record type which predates the C# record type, which is what I'm using for the user account. Yeah, here we go. Right, so the user account is a record type of user account. It allows me to take in these values, and you'll notice that these are null values, but because of the way that I'm constructing the user account, I'm constantly passing new state every time. So it's really kind of a builder pattern, right? Where I create a user account and I just constantly add the things to it. I add the authentication record to it when it comes back from the workflow pipeline. I add the expiring refresh token when it comes back from the pipeline. And then I have a valid user account at the end of all of that, right?
Got it. Okay. That makes sense.
So that's exactly what I'm doing here, is saying, okay, either error out, and I just so you know, I wrote this so that it takes the caller member name and the caller line number by default, just a trick that I wrote for debugging, so that I can see where the error is coming from when the error happens, as opposed to saying like the account you attempted, right? Like I didn't want those types of things. I while I'm debugging, I like to get information about the debugger. So I just have a new error that returns, and it'll tell me exactly where it blew up, and otherwise it'll give me a valid account, right? So then going back to where we're using this, right? So the interpreter can create an account from an ID, and it can also add an access token, right? And the user account has these functions on them, right? The has the ability to say, create an account, add an access token, right? So that's that fluent builder concept that I'm using to handle all this. Oh, there we go. Oh, you guys are going to start getting all the notifications because my do not disturb is up. Oh no.
Here it
right?
comes.
But here's the key, right? And here's where it all kind of comes together. I told you I was going to show you the validation in the app applicative, right? When I go to add an access token, let's talk about a modern day mobile app that you don't need to authenticate in order to use, right? Like a Yelp or a Yellow Pages or any type of thing that allows you to sign up but doesn't force you as a way to enter into the app, right? So I want to start with, hey, if you don't give me an email address, I'll just give you a GUID for this, right? But if you do give me an email address, I'll use your email address, right? And then when we get into the whole adding the access token, I have gone to the API, right? Remember we talked about result, authentication result, right? That's the type that the actual OAuth endpoint will return to us. We can then unpack it. And you talked about if checks, right?
Yeah.
I could write this as a series of if checks. Nobody would stop me. Nobody would say it's wrong. Nobody would say it's a weak way to do it. But let's look at a different way. Can I do that? No, I can't do that. Okay, that won't work. So what I do is I unpack the result. I take the result and I say match, right? If the result is successful, right, I create an optional from the result. I then map it and validate it, and then I use this to validation to force the validation and give me any errors that come out of it, right? And if I fail, right, then just give me another error, right? So now not only am I saying my success track is green, on my success track while I'm unpacking the result from the API, I can then say, oh, well, validate this thing. And this is where the applicative comes in, right? Because here we go. When I validate a record, I'm taking the authentication result. But again, when we look at the way my authentication result is set up, I'm going to have a user, which is a claims principal, an access token. And what happens if the API sends me a null access token, right? How do I handle that, right? Well, my validation and my applicative, remember I talked about how it was a tuple of functions, right? Notice this is a function, right? This is a function. And all I'm doing is wrapping it in a value tuple, right? And now when I go to apply via my applicative, I have access to the values that are returned from those function calls. So the claims principle. Now, and I also get to know whether or not there are valid claims, right? Like I want to know whether or not this thing has claims. How do we identify that? We say that the claims property actually has stuff in it, right? Simple. And now I take this applicative and I basically say, hey, when I go to get my result, validate it and send it back. So this gets into the whole if checks are dirty. And I'm at a place where I don't even want if checks in my code. Like if there are if checks in my code, I feel like I did something wrong. This gives me the ability to inline in a fluent syntax say, hey, I got a result from my API. Is it valid based upon my rules? And validate it.
Yeah.
All in one.
I guess I'm looking at it and I'm just thinking, I'm looking at the way that it flows.
Mhm.
I'm thinking it's almost like it's not necessarily that there's no if checks, it's just that it's just handled in a more fluent way, right? Because if so I'm looking at line, I think that's line 44. It's a little dark, but that looks like line 44 as an example, right? Like so no, you're using pattern matching
Yep.
instead of an if check, right?
Yep.
But still, like I'm saying if the value is faulted, do the left thing or the right thing, right? Like I'm still
Right.
it's the logic is still the same as what I'm saying, but like
The way it's presented is
the
different.
syntax to do it is just different,
Right.
right? So
Right.
it's not like I guess what I'm trying to say for me, it's not like I'm thinking about it a different way because we're still checking, right? Or we're still saying if this, do that, and
Right.
if not, do
Right.
the other thing, or
Right.
based on multiple states, do this for the associated state, right?
Right.
But now, like you said, we have a more fluent way to do it, and I'm guessing now that affects the way that we test it, right? Like, and you did show us an example of unit testing a little while ago, but like I
Yeah.
think is it? Do you find like this way for you is more readable and more testable right now, or like I guess I'm trying to say like if I have if checks
Yep.
and it's doing the same thing, it looks different, but it does the same thing. Why would I want to do it?
So let's talk about that, right? So again, I talked about this interpreter that I'm using to do some of the checks, and I wanted to write some tests against it, right? So these are the
Yeah.
either conditions.
Hmm.
Um, the reason why, like, look at this is a given when then, right? Like everything is a function, right? So like I think this is the hard part, right? Like this is where as a object-oriented developer, and this is where that object-oriented sandwich in the middle of the functional and the programming,
Hmm.
you have to make a shift to accept the fact that functions are your friend and pure
Yeah.
functions are life, right? Pure functions is what you want, right? Meaning that I like, and if I don't use the output of a pure function, Ryder will be smart enough to tell me, hey, Rodney, you aren't using the result of this pure function, which kind of violates the contract. Maybe you want to fix that, right?
Got it.
So everything just becomes a function wrapped in another function, right? Wrapped in another function. And like all of this just becomes a very succinct way to build out the way everything works versus the older school paradigm of, I mean, honestly, it's even hierarchical in nature if you think about it.
Yeah.
I'm going to write a whole bunch of if checks and if else, these things, and then eventually I'm going to get there. Well, I'm still doing the same, to your point, I'm still doing the same checks. And this is still an if check. For the record, this is still an if check, right? This is a ternary
Right.
operator. This is still an if check. Yes, I'm using pattern matching. The difference is now it's not a symptom of my function. It's the result of my function. Does that make sense?
Yeah, that makes sense.
So
And
I don't have if checks scattered all throughout this function. There's just one at the end that says, hey, I either return the success or return the failure.
right, and then we have that either at the top, right? Like like you
Right.
said earlier, like that's the transition between one result and another result, right? Like it's either this or that. And so
It's either
now,
this or that.
I'm thinking about it from the perspective of, I'm guessing now using that model along with like, support in your IDE and all these other things in the support in the language, like should I be writing now, or would this result in me writing less error prone code?
So I can't say definitively yes.
Okay.
I will say that for me, it has from
Okay.
just using RX. So now using RX and then applying this to my RX, I feel like I will have code, but more better error handled code, and
That's,
it's easier to read, easier to reason about, right? I don't have to write
yeah.
like I guess this is the point, right? When you look at this validate record, right? Hidden behind this function is a function, right? And then there's 3, 4 more functions that I use to make an applicative, which is yet another function. And then at the end of that has all of these things in it, right? So is it that it's less error prone, or is it that each piece has more of a single responsibility, and each responsibility can be reasoned about in isolation, right? As opposed to having to look at a 500 line method with 60 if checks in it. Who wants to do that when you can easily just say, hey, okay, I've got a result, I'm going to match on success, here it is, and then you just drill down, right? Like all of this, like again, add an access token to your code. Go write this yourself and show me that the if checks make it more readable, and I'll drink a glass of pilk, right? Like I'll do it. I don't care. But like the whole thing is you're not going to get me to believe it, because I've written application upon application upon application that has if checks. The most famous if check of all time, if you're a C# developer on the .NET stack, if is postback equals true.
Yeah. Yep.
I don't need that anymore. Now it just becomes a function that I wrap and remove from the reasoning of the logic. And now, okay, I can look at it and say, hey, this is an optional. It's going to map. It's going to give me a result. And if it doesn't, then I can down into it. As opposed to, hey, what line number did that if check say it was on? Like, who's got time to look at that, right? Yeah. I know for a fact that my validation failed, and I can prove it, I think. I hope. Let's see if we think we know what we're talking about. This is the hard part, right? With access token, with refresh token. So if I take these off, oh, I think this one might fail anyway. We'll see. Ronnie's not great at this. Oh, that's a much better. No, that one was broken. There we go. That one was already broken. Here we go. Here's a match, right? So what I'm doing is I'm saying, let's create an account, right? And I'm saying I have to have a valid user ID, which is hello. So right now, if I run this, right, I get that, and we'll go ahead and create a separate session so we can look at it in isolation, right? So my thing passes, right? Because it has hello as the user ID. The second I take that out and I try and create an account, here we go. Let's just give it an empty string. And let's see if the demo gods are with me. Oh, it's still passed? Oh, because empty is valid. Empty is valid.
It's a valid state, because then you would handle it in that other condition.
Right. Empty is valid state. Oh, goodness.
So what if he did null? Okay, yeah, there you go.
Yeah, null should break. Let's see if oh, I love it when everything blows up. Oh, it's still. Huh. Are you? Oh no. Oh no. I broke it. Oh well. This is what happens when you mess with code like the night before a demo.
but I think I understand what you're saying. And
I know why it's passing, because of this. I should be throwing right here if I get an error.
If you get an error.
Long and short, what I'm doing is like, and I can put a breakpoint here and prove it. I don't think this is going to hit. If I hit the debug, the unit test, it's probably not going to hit that. Yeah, it's not going to hit that breakpoint. Yeah, see, there you go. But if I then turn this back over to hello, it's going to say, hey, I've now matched on hello. Come on, prove me right. I did this yesterday. I promise you I did, and it worked. Haha, there we go, right? So now my match says that I have a valid account, right, from the either, and I have an item. It gives me the account ID, and it should be the user ID that I passed in. Boom, right? And now if this explodes, all I have to do is go look for the either, right, that returns from this and say, why are you erroring? Give me the exception, because this returns an actual exception in some cases. Give me the information. Why are you erroring?
Right, because in the either, right, either being like the transition between the states, that is where like you'd actually be collecting the information about the transition between like one state or the other. And so in transitioning to that error state, and I'm just repeating so I can understand what's happening.
You're good, man.
But like as I'm transitioning to that error state in the either, I'll be collecting, I don't know, validation or exception, or like what's the thing that happened? What's the bad thing that happened? And then now, as I'm consuming the either, you know what I mean? I can again dive into it and understand what's going on.
Exactly. So let me see if I can find that interpreter. There we go. Right, and that's exactly it, right? Like what's happening is when I create that account from an ID, right? I'm going and calling the create account method, which is on the user account, and I'm basically saying, hey, is it null or white space? throw an error. And here, if it is, I could throw an actual exception, right? Like if I wanted to, I could try, catch, and swallow and do all that stuff. But I know what my validation is, right? Like I know I don't want that string to be empty. So why would I let the compiler throw an exception when I can just check for it and return a valid value? This approach is about making exceptional things less exceptional and making them normal so we can handle them in our normal coding process, as opposed to handling them as exceptional cases.
Okay. One more question.
Yeah, sure.
I actually have a ton more questions, but we're running out of time. But I do have one more question. So right back where you were before, in that area where you were showing the either, right? You had that left and that right function. In the condition, right? So in this case, your condition on line 28, right, is null or empty. What if I had multiple conditions and each condition had its own error message or whatever the case? Like, what if I had compound validation rules? I guess is what I'm saying. Like, would I have different functions for those, or like how would I do that?
So to answer the last question, if I have compound validation rules, you're going to use that applicative concept, which is validate record, right? Again, I'm validating the entire result, but I'm validating different pieces of the result individually so that I can create different inputs for my authentication record, right? I'm handling are claims valid? Is the access token valid? I'm checking the return from the API for everything that could be exceptional in my application and making it normal.
Okay, got it.
Right? Now, the other question you asked me, ask that one again, because I don't think I got that.
So it was, right, so there you have the left or the right, right? Like I'm wondering, well, I guess it's kind of the same question, right? Because there's more so around if I had multiple states or multiple validations that I want to do, like would I put like right now you have is null or empty, right? Like would I compound those all together, or would I have different validating functions? And now I would like aggregate all the things that are wrong and put it in like one either.
That's what the applicative does.
Okay.
Right. So okay. Now I think I understand what you're asking. Right. So to your point, if we were to validate the record all in one function, right? So again, let's talk about single responsibility. Solid. Single responsibility. A method should do one thing and do it well. Right.
Yeah.
So should my method that validates that the result has claims be muddied with the concept of that it has an access token? In your traditional C#, you would just run through a bunch of if checks, right? If it has this, if it has that, if it has this, then we take the results, we mutate it somehow, we stick it in some new object. Instead, what I am doing is I am creating single responsibility validation functions. Validate that this thing satisfies this one concern. It has claims. Validate.
Right.
It has an access token. Validate. Right. And then I take the result of all of those validations and run it through this apply method. And if they all succeed, then I get a value. If any one of them fails on its individual either, right? Because a validation is an either type, right? So if it fails, it will blow up the applicative and I'll get an error back that tells me what broke.
Got it. Okay.
So it changes, again, you have to change the way you look at it, and you can't have these same OO paradigms where I'm just going to stick everything in one function and run through a bunch of if checks. Everything has to be red or green, and each method should return red or green. And you should seek to make every method as small and as minute as possible so it is doing one thing and doing it extremely well. That is one of the things that I have taken from Solid as I'm looking at my functional code these days.
Got it. Okay. Here's what I think we should do.
Sure.
We should continue talking about this in a future stream. And what I actually want to do, I don't know how we're going to do it, but I think what will be interesting is if we go through an exercise and do like a conversion, right? Like here's some code and let's convert it to use some of these functional styles. Because like I'm looking at your code, I'm like, okay, I got it. That makes sense. But I think what would be more helpful for me and maybe for other folks too, is if we had like some to-do API style examples. You know what I mean? I know everyone hates to-do app. Maybe we'll call it like, I don't know, we'll call it like a recipe API or something like that, like something interesting. But then let's kind of go through it and like convert it you know what I mean, like convert our validation.
Oh, you're talking about like taking actual the website, the actual website, and convert it.
Yeah, like and I
Okay.
just
Yeah.
converted to use like, you know, to use look like options and maybes and eithers and stuff like that. You know what I mean? I think that could be like an interesting on-screen like exercise that we can
Do
maybe
you
do.
happen to have a sample that I could take and modify? Because like that's the main thing with me. Like going and writing imperative code these days is like pulling teeth for me.
I mean, I could find one.
Yeah, just give me one and I'll gladly hack
I
at
could
it
find
and
one.
see what we can do. Yeah, because that'd be
Yeah,
a
I could
great
find one.
exercise, right?
That's pretty fine. I'm pretty sure I have code on my GitHub that we could like, you know, repurpose or whatever. So
And to that point, this code is going to be available on the inside.net GitHub shortly hereafter.
okay.
I'm gonna push it up as a repo called FOOP, which is functional object oriented programming.
Nice.
There you go.
All right, awesome. And then again, we'll make sure we put that in the, you know, in the description too. So if you know, if you're watching this later and you didn't get to watch this live, you'll be able to see see the code and, you know, play around with it if you want. But with that being said, Rodney, this was great, man. I always feel like I learn tons of stuff from you, particularly when it comes to like functional and reactive, and like I think like just like these alternative ways of thinking about creating readable code. You know what I mean? And I think even to some extent like code that I feel more confident about, because I think that's the whole point too, right? It's not just about like, you know, trying out new stuff or whatever. It's about like when I deployed the thing, like how comfortable do I feel that I can walk away and I could go eat lunch, and between the time I leave my desk and come back, like everything doesn't blow up, right? Like I
Look,
need
I try and write code that I can deploy on Friday and go on vacation.
exactly. I love that. I love
So
that.
that's where I'm at.
Exactly.
Yeah.
Cool. So folks, we'll be back again. Make sure you subscribe to our YouTube channel. And you know, when you hit that subscribe button, you'll get to know when we have other, you know, streams and stuff like that coming up. I'm pretty sure we have at least one next week, maybe
So
two.
next week.
Next week, Wednesday? Is it Wednesday?
I don't think next week Wednesday. I think it's Monday. I think
No,
Wednesday.
Monday's a holiday, so we don't have one on.
Oh, so then it is Wednesday. Oof.
Okay. All right. So we'll go ahead, go to the YouTube, check it out. If we have one, it'll be on there. You'll figure it out. And yeah, and if you have any thoughts about other things that we could talk about, you know, feel free to reach out to me on Twitter. Rodney's also on Twitter. You know, we're on YouTube and LinkedIn and all the places. So definitely let us know. Yeah. With that being said, have a good day and bye, everybody.